Alright, hey guys. Forgot I had my microphone muted, but welcome to the stream. So, if you were here for the last stream, you'd know that I was further behind when it started than I was the stream before in terms of features of the Locomotion system. Unfortunately, I'm going to have to continue that trend. My project, I'm not sure what happened with it, but the animation blueprint started crashing the whole thing. I read through the log files and the crash reports. It had something to do with an array that I had created at some point, and of course I couldn't open up the animation blueprint to fix it because even right-clicking on said animation blueprint would crash the whole project. So I started over in a new project from scratch, and well, don't mind all the hellos that are being printed on the side of this screen. I was just trying to debug something, and well, we have distance match starts and a loop state with, I think, orientation warping that looks better than it did before. You'll notice some big jumps right now. That's not because of the orientation warping. I've been playing with some other things, namely foot sliding. Not foot sliding. I meant to say foot locking. So I think I have a test animation loop, a test blend space here with a couple of starts that are being blended together. And the usual Paragon approach is to use the first footstep to blend during the first footstep and then blend over into orientation warping with the main starting animation. But these animations do not blend together well whatsoever. It's the forward start and the left start. I honestly don't know how these two animations could even work together in Paragon. Um, the yeah, maybe the start could be offset somehow, but I don't know. But what I did find looks really nice is just orientation warping a primary start animation like you do in the looping state. But the moment you do that, I'll open up the animation blueprint to show you guys. And don't mind the mess. I know it was really nice and neat the last time. The mess here is the foot locking stuff I started to play around with last time. So if I turn all of the foot locking off, actually no, I would not turn it off here. I would turn it off in my anim graph, but again, I have way too many tabs open inside of my animation blueprint. So I will bypass all of this and compile it. And you'll notice if we put this in slow motion that the legs rotate around. And there's that weird blend there because I was using inertialization and then I deleted the inertialization node because I can't remember if it's supposed to go before or after IK. So I'll add that back in there. And of course, stops aren't implemented yet, but the legs rotate. And what I want to do is I want to get rid of that rotation by implementing a foot locking system. But before I show you guys what I figured out with that so far, which isn't much, I actually have the Advanced Locomotion System V4 open here, and we're going to be looking at the foot sliding in that, and I'm just going to try to replicate that inside of this project. Did I say foot sliding instead of foot locking again? Gosh. Well, it's supposed to stop foot sliding, so I guess it sort of makes sense why I'm mixing the two up. Even though I'm not, I'm just saying the completely wrong word. I guess maybe that's mixing them up, but I have them straight in my head, so I don't know. Anyway, I will go ahead and add an inertialization node back in. I'm pretty sure it goes before, it would make sense to go before the IK. So I will put it there. And why are we A-posing? Oh, because the IK isn't plugged in right now. That's why. There we go. Alright, now our blends are much better with the orientation warping. A friend of mine actually shared his bone structure, the structure of the bones in the orientation warping nodes. And he actually included the left and right clavicle. I can't remember where he said he found that, or where he saw that, but I tried it and it looks a whole lot smoother in my opinion. And right here, I'm just taking the direction, I'm adding an offset, normalizing the axis, and clamping it so that when the smoothing is turned off on the orientation warping, the feet don't rotate around more than they should while you're in the middle of a blend. I'm clamping the maximum angle in degrees that each orientation warping node can rotate the character by, so that we don't over-rotate during transitions from one direction to another. Anyway, I really want to try to get foot locking set up for this, so that when the feet are on the ground, they lock, and when they're off the ground, they're unlocked. Because that should hopefully allow the start transitions to work. It's kind of here, but it's very rudimentary, and the orientation warping is disregarding it anyway. As you can see, the feet just rotated there. And if you have an animation set where the animations actually blend together like they should, and they don't, do. For a couple of you who have joined the stream since this during the blend, like this Paragon animation is doing, then foot locking probably won't be a problem, but well, at least this Paragon character does it. I want this locomotion system here to work for all Paragon characters. So, foot locking is what it looks like we need to do. So I have the advanced locomotion system opened up here, and it's been a long time since I've so much as looked at or glanced at anything inside of here. I believe gosh, I'm not sure if I used this system at all since I made that video on using metahumans with the advanced locomotion system, actually. It's character assets, isn't it? I just prefer to make my own animation systems. I have a lot of fun with it, as you guys can probably tell by the amount of content on this channel about locomotion inside of Unreal Engine. So, let's see. That's spine rotation here. Foot IK. So we have three variables here that are controlling each foot. Footlock L location, footlock L rotation, and footlock L alpha. And again, I haven't looked at this in a long time. I don't think I've looked at the footlocking specifically in over a year. So I'm learning this as I go. I'm just trying to put this together in my mind. So a transform modify bone for the IK foot bones. I'm not going to worry about any of their offsets or knee targets. And then they're using 2 bone IK. I would like to try to just use a leg IK node, but we'll see how that goes. And it might be better at this point to try doing this in control rig, but I'd prefer to do it with this kind of setup, and then maybe try to move that over into control rig in another stream. So I'm just going to search up this foot lock just to try to find the location variables and where they're set. So we have an update foot IK function, but it's already taking these in. So let's try to find where these are set. I forget how expansive this animation blueprint is. It really is. It's crazy how much there is here. Alright, so I guess I will head over to the update graph. And every frame foot IK. So we're getting a curve value of the foot IK curve name, and if it's greater than 0, so the curve would be a no sort of transition from the keys, just a constant transition, not linear or automatic or any of those others, which is what I think I have in, yeah, that's what I have in my project. So you're setting, okay, a local curve value, that's simple enough. Only update the foot block alpha if the new value is less than the current or it equals 1. This makes it so that the foot can only blend out of a locked position or lock to a new position and never blend in. Okay, that's interesting. I will, that's interesting. I've never seen that before. So step 3, if the foot lock curve equals 1, save the new lock location and rotation in component space. Okay, that makes sense. And if the foot lock alpha has a weight, update the foot lock offsets to keep the foot planted in place while the capsule moves. So if the feet are locked, we want to set these variables. That makes sense. So we're using a sequence, delta between the current and last updated rotation to find how much the foot should be rotated to remain planted on the ground. So what I think I'm going to do, I'm just going to duplicate all of this stuff directly into my animation blueprint. So I'm going to put it on my second screen. And I'll check back in on chats periodically, since that's where I have my second screen at. So if I don't respond immediately, it's because I'm moving stuff over from the advanced locomotion system into this blueprint. So I think I'll show you guys what I came up with. It's pretty simple. I'm just interpolating the footlock alpha so that there's always a smooth blend and not a sharp jump. And then when the project starts, when I first start, I update the curve, the location, so that the feet aren't just stuck in the center of the world, because I'm doing this in a world space. Then I'm getting the curve value, and if it is greater than 0, well, if it's not greater than 0, which means foot locking is turned off, I update a left foot lock location so that the feet move along with it, and a right foot lock location. And I check each of those independently with the branch, and if, it's at 1, then I don't want to update. And I just read the curve value. And honestly, that might be causing some issues here because this logic is set up as if there is no blend, and this one is set up as if there's to create a blend. And things are really out of order here. This is something I threw together, I think yesterday morning when I was working on this, within the last 30 minutes or so before lunch. So not as organized as I'd like it to be. But I'm just going to copy the advanced locomotion systems approach to start. So I'm going to just delete all of this. And I'm going to create a new function. And let's see. Going back over to the update foot IK function in the advanced locomotion system, and I'll start with that because we'll want to do more with foot IK. That we'll probably do that in control rig, so this will probably be temporary until we can move it all over into control rig, but for now, this function will be called update foot IK. And these debug spheres are just spheres drawn at the footlock location, so it's easier to see what's going on. So I don't think this takes any inputs. Nope. Okay. Oh, I opened up the wrong function. Did I put update foot IK in there, or did I put the wrong function here? No, I put it in here. Okay. So now we need a set foot locking function. And it's going to have, first we have 3 string inputs. No, name inputs. Enable foot IK curve. And foot lock curve. And IK foot bone. Now we have a, let's see, we have a foot lock L alpha, or not foot lock L alpha, that's their input. It's a current foot lock alpha. Reading from the wrong spot. Which is a float, and I'm on preview 2 now, and for preview 1 they changed floats to reals and then back to floats. I'm not sure why, and I'm sorry if you guys heard that. I just bumped into my desk in a way I didn't intend to. I'm not sure if I might pick that up or not. Anyway, so yeah, they're named floats again, and you can't do math with them. Oh, well, you can, but I swear the divide node. Okay, so sometimes these math nodes don't work. Sometimes they do. It's some sort of bug, I guess. You can always get around it by converting the doubles, but I don't know. It's odd. So our current footlock location and our current footlock rotation, which is a rotator, of course. And so I have some variables here. I have a right footlock alpha, a left footlock alpha, a left footlock location. I want to use the same naming conventions, so I'll just shorten these 2 variables. And I'll create 2 more. An L foot lock rotation and a R foot lock rotation, I almost said location. Okay. So now so now that we have all of these inputs, I'm going to go back into the update foot IK function, and I'm going to take 2 of these set foot locking functions. I'm going to plug them both in here. Now I do not recall exactly what I named the footlock curves that I have, but I have them on the start and the forward start and the left start animation so far, so L foot down and R foot down. It would probably make more sense if I renamed these to L foot locked and R foot locked, so I will do that. I not always just want to lock the feet down when they're down. There might be other situations, so there we go. And I also should put that on the one other animation that I have these curves in. Oh, alright, so in that case, I'm just gonna It's giving me trouble. I don't want to redo these curves, so I'll leave it as L foot down and R foot down. It doesn't really matter. Well, this is enable foot IK curve, so whoops. I'm doing this all wrong. There we go. And there we go. And I guess that's a useful curve to have, so. I'll need to add it to the two animations that I've been testing this with. It's just a force of habit to go back to this window to open the content browser. I know I don't need to. I don't know why. It's just I have an animation asset that I can get to fast, so I have this one. I could search these from the animation graph, so pay no attention to my workflow. I'm doing things the slow way today, apparently. So we'll create a new curve, enable. Oh. And then we will also do enable foot IKR. Oh, that's odd. Did you guys notice the switch with the audio? I think it just swapped microphones on me to a microphone that I'm not intending to use right now. Just a second here. That's odd. Yeah, it just switched microphones. Wow. Okay. Let me fix that. Okay, maybe it didn't. No, it definitely did. Alright, give me a second to try to sort this out, guys. I apologize. Gonna turn this one off for now. Okay. I think. Yeah, okay. Audio should be back to the way it was before. I apologize for that hiccup. I think I have too many things plugged into this power strip under my computer right now. I'll have to switch some stuff around later. Anyway, we're going to add another curve and enable foot IK underscore R. I'm going to add a single key to each of these. I'm going to set that key to 1. And I will go in and add these curves to other animations, but for now, I'm just testing all of this with the forward and left start animations. So next we have our IK foot bones, which would be IK foot L and IK foot R. Go get a drink real quick. And now finally we're gonna use our foot lock. I'm gonna plug in our foot lock variables. So give myself a bit more space between these two. And okay, now we can finally set up the logic inside of this function. So, let's see here. So the first thing we're going to do is we're going to check to see if foot IK is enabled. We can check by checking if its value is greater than 0. And see, here we go. Here's that weird issue. No matching greater function for float single precision. So I'm going to have to make this a double. And then plug it in. I really do not understand what is going on with this bug in the preview. I mean, I understand probably it was probably caused because of the switch from single floating point numbers for lots of things to larger floating point numbers for larger worlds and things, but apparently something got bugged from in between preview 1 and preview 2. And now the advanced locomotion system uses a sequence here with 4 pins. And the first thing we're going to do is we're going to set local footlock curve values. So that means we need a local variable, which I will name, I put it local underscore before all of my local variable names just to make things easier to read and understand. And I cannot type today, apparently. See, I say that as I think I've typed it correctly. Typing around this microphone throws me off. I'm not sure why. Okay. So, let's bring this all the way over here. Let's get curve value. And for input, we're going to use our input for the function, which we named footlock, I think. Footlock curve. Yep. And I'm going to comment this. I just like the look of black comments better than a regular default, so I've changed the default in the editor preferences. And I'm way too used to camel casing my variables. Honestly, I'm not really following many conventions with my comments. I use sometimes I might, yeah, this is the first time I've actually thought about how I'm typing things into a comment, so I'm sure at this point it's not worth the effort. So there we go. Now step 2 is only update the footlock alpha if the new value is less than the current or it equals 1. This makes it so that the foot can only blend out of the locked position or lock into a new position, but never blend in. So, let's see. Okay. So, we're going to get our footlock curve value. We get our current footlock alpha input. And we're going to check if this footlock curve value is, see, local variable works with greater than. Global scope variable, or no, it's not even a variable. Maybe that's it. Who knows? Who knows? I'm hoping it's a bug that will be fixed. And that probably come, I want to say, and this is not an April Fool's, guys. There's actually a State of Unreal stream It's going to be coming on the 5th of April. And there's going to be like an hour or 2 hour long news segment with Tim Sweeney, the CEO of Epic Games, and I can't remember what the name of the CTO of Epic Games is, but they'll be there too. And then after that, there's going to be a whole breakdown on how the Matrix Awakens demo was created. And the only possible reason that I can think of there being a live stream with for the State of Unreal with the CEO of Epic Games, maybe it's an every year thing, or maybe not. I don't remember, but I feel like it's going to be Unreal Engine 5. I've had this feeling that something will be coming out soon here for a while. And it sounds like the heater just turned on in the over there in the background. I'm not sure how well I'm filtering it out. I'm not as experienced with using all the audio filters in OBS as I am when DaVinci Resolve, which is what I use to edit my videos. Alright, so I'm looking back at the advanced locomotion system. And so we're seeing if this is greater than 0.99. So this is if the foot lock curve is enabled. Actually greater than or equal to. Probably safe for the greater than, but I'm just gonna be extra safe. And then we're gonna use an OR node. And if it is less than the current footlock alpha, we are also going to set the current footlock alpha with the footlock curve value. So let's get our branch. And gosh, I really can't type, so we're setting our local foot. No, we're setting. That's interesting. So that's this. No, we're setting our footlock curve value, which is this local variable, and we're setting it with the current footlock alpha input, and that will be the second step of our function from the straight out of the advanced locomotion system. And again, I'm just gonna straight up copy the text from the comments here. It's easier than trying to type it all out. Okay, so step 3. If the footlock curve equals 1, save the new lock location and rotation in component space. Personally, I'd prefer world space, but we'll try it in component space and see. I'd like to change it to world space and get it to work with that. I think it would create a less complicated system. But I know this system works for the most part. There's some issues with the starts and the advanced locomotion system if you tap them, but I can look at the community version of the project where I'm pretty sure that's fixed and see how they fix it and make those changes off stream. I didn't have enough time to download that before I started the stream today. Okay, so we're going to get our current footlock alpha. And again, if it's greater than or equal to 0.99, If that is true, I mean, let's get a branch, and if that is true, we're going to Okay, I did this backwards here. I'm not using references right now. So the advanced locomotion system is, so what I'm going, so I read that node backwards in the advanced locomotion system. I want to set the current foot, and I see how this is set up now. You're passing this by reference so that you can set it from inside the function. Okay, that's an interesting approach. Okay, I see why you're doing it that way now. Okay. So let's change these. Gosh, I've barely worked with references in the engine. I understand how they work, but I do not recall how you input or even create one or change an input for a function to be one. Let's see. So, Yep, I will save the stream. All the streams that I do are, as soon as they're over, they go up on my channel as videos automatically, and you can go back and watch them. Okay, so going a bit slow here. I apologize, guys. Let's see. Right, references. The inputs are just, So how are they converting it to a reference? I feel like, I don't know. I really should know this. I teach Unreal Engine on YouTube, and I'm not even sure how to set a function to take references as an input. It's Ah, there we go. It's in the drop-down menu. Okay. It's just been too long since I've worked with these this way. So awesome. Now, I think if I... Okay, so back into the function. And on the topic of, so on the topic of these streams, I mentioned it before in a previous stream, but all of these Locomotion streams are building up to a new series. The first video is probably just going to be a video on setting up Locomotion with Paragon characters, but then I'm probably going to start using animations from one of the marketplace animation packs and go into a series that's just on Locomotion inside of Unreal Engine 5. And some of the really awesome new features and all of that stuff. And I want to have the system pretty much figured out before I start it, and so that's what these streams are. It's me figuring out the stuff for my next series on YouTube, and I don't want to make you guys wait this long, so I figured why not stream it, stream me struggling to figure these things out so that you guys can share my pain. Locomotion systems, it's crazy how complex they can get, but it's so much fun to build them. So let's see. Where were we? I keep losing my train of thought. I'm terrible at staying focused on these streams. I just start ranting. Okay. So let's get our current foot lock. Oh, fun. This isn't going to make a difference. I really don't think it is, but I don't want Unreal Engine to give me any trouble because it didn't update the variable right there. Copied this straight from the advanced locomotion system. Gosh, come on. So am I converting this to a double or that to a double? Let's see. I really don't get this bug. Hmm. To understand why this here, I'm not able to get. I really don't understand what the heck is going on here. I could just do this a different way, which I think I'll do, and I don't want to waste the stream time trying to figure out why this approach, the advanced locomotion system approach for using the references, isn't working. So let's see. I'll name this set. Gosh, I'd love to be able to use one function for both and call it twice. So I'd love to use these reference variables. These reference inputs, I'd really, really like if I could just get these to work. So let's see if I can get this figured out in 3 minutes, and if not, I'll take a different approach. Okay. No, that won't do it. Alright. I'm really not liking this bug in preview 2. So, it's not giving me any options here. Unless I am setting. I don't think that's the case though. No, it's not. Alright, so we're not going to use references, but we are going to use the logic of the advanced locomotion system, even if we don't go about it in the same way. Alright, so let's see here. what we are trying to do is we're trying to set our input foot lock curve value with this foot lock alpha. And because this is a sequence, all right, so we are going to create a new local variable, which is going to be local underscore current foot lock alpha. And we're going to do the same thing for all of our inputs. We're going to do a local current foot lock location and a local underscore current foot lock rotation. And I'm going to set each of these in sequence if this is true. Because if not, there's no reason to waste CPU cycles. Wouldn't make that much of a difference, but I still like to optimize where I can. So now we have local variables to store these changes, and then at the end we can return these local variables and outside of the function set to the input variables. It's not as elegant, but it works, and it fits with the methods that I've been using for the rest of this animation blueprint. So yeah, okay. So now we can just set local foot lock curve value with our local current foot lock alpha. And there we go. And we are back on track. So now we're going to set our current, that's what's going on here. I named these backwards. So we're going to set our local current foot lock rotation and location with so we're going to get the owning component. Going to get socket transform. And we will split the return value. And the in-socket name will be the IK foot bone. And the space will be component. Now we can set our location and rotation if and only if the current foot lock alpha is greater than 0.99. So I'm going to add a reroute node right there to keep things tidy, and I'm going to also bring this in. And comment it. Again, I'm copying the text out of the advanced locomotion system into my blueprint. So there we go. Finally, we have one more step, which is if the footlock alpha has a weight, update the footlock offsets to keep the foot planted in place while the capsule moves. So again, current footlock alpha. This time, if it is greater than 0, this should be greater than equal to 0.9, greater than or equal to 0.99. Yeah, I didn't speak clearly there to begin with. Gonna get a branch, and we're gonna create a new function that is set footlock offsets. First, I'm gonna plug that in, add a reroute node, and comment this. Also gonna compile and save, just in case there's a crash or anything. I don't want to lose my progress. Alright, so, new function. And this one is going to be called set footlock offsets. I'm gonna give it 2 inputs. Location and rotation. Okay. We're gonna get a sequence here. And give it 2 more execution pins. We're gonna get a branch. And we're gonna check whether or not we're moving on the ground. Which we will be. There's no need to check. Because I'm going to be putting this inside the update ground state. The update ground. What? I can't remember what I called the function. The update ground state values function, which once there are more state values, I'll put in a boolean to make sure that we're on the ground before we update any of this stuff. So because we know we're grounded, we can just go straight to setting our rotation difference. Is that a local variable? Yes, it is. Okay. So 2 local variables, local rotation difference, which is a rotator, and then a local location difference, which is of the type location or vector. Now we're going to set our local rotation difference off of this first execution pin in our sequence, and to do so we're going to get the delta between the actor rotation and the last update rotation, which I have as variables set elsewhere inside of this animation graph. We have a previous rotation, which I am setting in my cache function, which I'm calling at the end of my update graph, and then we have our actor rotation, which is in not ground state values, locomotion values. So, okay, now off of the second execution pin, we're going to set the location difference. We're going to get an unrotate vector, and we're going to unrotate the velocity times world delta seconds. And I believe I have velocity as a variable under locomotion values. Yep. So velocity times, and I also have delta time. And I'm also going to get world rotation of our mesh. Alright, next we are going to subtract the location difference from the current local location and rotate it by the rotation difference to keep the flip planted in component space. So that makes sense, and it's why originally I was using world space. I'm not sure what the advantages of using component space are, because you would not need to do these extra calculations if you were using world space. So in this case, we're going to, yelling again. We're going to return to, okay, we're going to condense these two execution pins into a single one, and we're going to add two return outputs, a location and a rotation. We're going to output, we'll just name them that. We cannot, okay. Offset location and offset rotation. Return after we do these two things, and then to get these values, we're going to get our input is named location. So let's get location, and let's subtract location difference. And I should follow my naming conventions with my inputs for my functions in the project, which has been adding a current before each of these, so they're easier to differentiate between actual project variables or even local variables I create within a function. So we're going to rotate this around an axis. The axis is going to be the yaw of the rotation difference. And instead of splitting that pin, I'm going to get a break rotator. There's no functional difference. And this is saying -1 on the Z, so I'll trust that, and I'll put the offset location. Now we're going to do something similar. We're going to get our current rotation. And we're going to get the delta between it and the rotation difference. It'd be awesome if this would work on the first try. The probability of that is close to 0, but it would be awesome. So now that we have this function, we can go back into our set foot locking function, and we can call our set foot lock offset function off of true, and as inputs we can input our local current foot lock location and our local current foot lock rotation. Okay, so now that we have this function here, according to the inside of the advanced locomotion system, that's where the set foot locking function ends, which is not what we are going to do because we made local variables instead of using references. So instead, we're going to add a final execution pin onto the sequence, and we're going to get a return node. And we are going to return a vector, a rotator, and a float. What we're returning is foot lock alpha. The vector we are returning is foot lock location, and the rotator we're returning is foot lock rotation. Just double checking, so current, so yeah, okay. All right. And it looks like this is actually, as far as ALS's, the Advanced Locomotion System is going, this is occurring before this. I'm not sure why, what the logic is behind it. But if we are following their reference structure, then we're returning before we're setting our local current foot lock location and rotation, which will get wiped at the end of the function, so it will so never mind that, and hopefully it works this way around. I don't see why it wouldn't. Oh, and we're not returning our alpha. My bad, we are returning our foot lock curve value. Okay. So we can compile that and go back into our update foot IK function. Now I have a foot lock curve value, a foot lock location, and a foot lock rotation output, which we will then use to set foot lock alpha and foot lock location and foot lock rotation for the left foot, and then we'll do the same for the right foot. So I'll copy the variables for the left foot and I'll replace them with the right foot variables. And then plug them in. Now, almost at the moment of truth here where we will see if this advanced locomotion system implementation works implemented directly into here. Let's go back to our update graph. Okay, so I'll keep drawing the debug spheres. Now, let's see. we're going to go to our anim graph. And let's component space for both of these, I think. And also replace existing, I think. Let me double check that. I'm pretty sure, but I'm going to double check just to be safe. Replace existing in component space. Yep. Okay, cool. We don't these nodes anymore. We're going to use left foot alpha and right foot lock alpha. Give myself some more room to work here. And we're also going to get the left foot lock rotation. Use it as the other input. And we're going to do the same thing with the right foot over here. And let's just see what happens. Oh. Well, we crashed. That's not good. I'll try sending that and restarting the project, but while that does so, I'm gonna look through this log on my other screen actually. And before I try to open up that animation blueprint, gosh, this log is long. Okay. And most of it is printing hello to the screen too. Alright, here we go. I think I found where it crashed. I'm not seeing anything here. Alright, so I'm just gonna okay, yeah, it really scared me for a moment because uh last time it crashed like the for you guys who weren't here at the beginning, between this stream and the last one, my old animation blueprint just started crashing the project, and I was worried something similar was happening here, but I can open it, which is a good thing, but if I save it, it might crash, so what happened? What the heck happened? I really have no clue. It could have been a random crash. I think it might have been. I honestly think it was. Because the only thing that wasn't saved is me swapping out the inputs here. So left foot lock alpha, right foot lock alpha, I'll organize it later. Left foot lock rotation and right foot lock rotation. Get out of the middle of my screen. There we go. Okay. And I also want to change this to component space. Make sure I'm not ignoring the rotation. Okay, yeah. Compiled and saved with no issue that time, so who knows what happened. I didn't see any errors at the bottom of the log, so yeah. Okay. moment of... Okay, so something isn't working. I think it... So that looked all normal, but forward looked, well, not normal. So what's going on there? And okay, I'm gonna go back over to my update graph, and why are these debug spheres not drawing? I mean, they should be drawing, but they're not. They should be drawing where the feet are at. And gosh, I'm really happy with how the orientation warping turned out. And if this approach works with the starts, I might be able to get it to work with the stops there. They'll be less troublesome though. So we're starting, and that looked fine. But forward brakes, and it could be a case of maybe, let's see. Let's compare what's going on in jog left start. Not having an enable foot IK curve. That would do it. So it's not that the forward animation isn't working with it, it's that the left animation doesn't have the curve. So now, hopefully it'll break the left animation. Oh. Oh. Okay, let's see. I was calling the right animation the left animation, my bad. And I was trying to go left. Anyway. Yeah, it breaks. No wonder the right animation looks normal. I got my, yeah, I got that switched around. So, okay. What's going on? Let's go back to the animation graph. And we could, I'm gonna print left foot location first before I do anything else. I'm just gonna read that out and see how it changes. So I do not want to print into the log, and I do not want the duration to be 2 seconds. Forgot about that. It's not being updated. That is a good first step, and that's what I thought was happening. So, let's go back to our update foot IK. We're setting this left foot lock location variable here after we return from this set foot locking function. We're only doing it if enable foot IK underscore L is, that curve is true. It would be because we are setting the alpha based on that. So the alpha would be 0, and we would not be locking the feet to 0. So something's wrong here. Is the IK foot bone not... Do I have that input incorrectly? Is it case sensitive? That could be my issue. Let's see. No, because these are all lowercase, so not that. The left foot lock location is not... It's being a... It has to be being set, so we're setting it from the function, from the second execution pin. Alright, let's set it again right here. Like I think that we would, otherwise this function's doing nothing. So I forgot that. No better. Still 0. So this here is what's not working. This could be working. So current foot lock alpha. Wait a second. I think I might see what's going on here. We're getting the curve value for the enable foot IK. And if it's greater than 0, if that's true, then we set the current footlock alpha with the current footlock alpha input, which when we are inputting what are we setting that with? The enable foot IK curve input? Yeah, the enable foot. No, we're setting that with current footlock alpha, which is... Ah, I see. We're not setting the footlock alpha variable. So how is it structured in the advanced locomotion system? So inside of update foot IK, we have a footlock L alpha, which we input into current footlock alpha. And inside of the node, we pass it in via reference and we do update it. So that part, that matches up, but we have to be setting footlock alpha somewhere else first. So set footlock L alpha. Nothing. Excuse me. And I'll move the advanced locomotion system over onto my main screen so you guys can see. So we're getting the variable, but we're never setting it. Why? We have to. There's no way. There's no way. If the enable foot IK is true, then the first thing we do... Oh, I did something backwards because this does not match with what I did. Why the heck did I... Oh, I'm setting a local current footlock alpha, so never mind. I was thinking I was setting that variable. I did not read close enough. So I'm setting that with the inputs, and then I'm setting these again. But I'm never setting footlock alpha. I'm setting local footlock curve value, which is the same thing because I'm outputting it as footlock curve value, and then I am setting the footlock alpha. Alright, so, only thing I could do here is well, not the only thing, but the next thing I'm going to do is I'm going to get another print string, and I'm just gonna print it in red so that I can tell it apart from the others. Duration of 0. I don't want to print to log. And I'm going to print the left foot lock alpha. It should switch periodically between 1 and 0. It's staying on 0 the whole time. Oh, well, I'm past my start. Okay, there. Now it's at 0.9498. Huh. That's an odd number. But it is updating. So that's fine then. I'll worry about the weird value of that later. It's close enough to 1. So, but it's not close enough to satisfy this check. I'm going to bypass this branch. Wait a second. Wait just a second. Do I really have it that backwards? Yes, I do. Okay, I see. I got my variables confused. We should be setting alpha with value, not value with alpha. That does make more sense now that I actually think about it instead of just mindlessly copy it. Yep, because now we get up to 1, which would satisfy that which would satisfy this, which would mean that it would set the local current foot lock location with the location of the IK foot bone. Okay, so let's put this in slow motion. Yes, our value is changing. That's interesting, though. It's changing. It's like messed up. It's like, but it's changing. So that's good. It's locking, but it's not locking correctly. So we're doing this in component space. Gosh, I want to see what happens if we disconnect this. Just delete that. If we get it in world space. So now if current footlock alpha is greater than or equal to 0.99, we set the local current footlock location and the local current footlock rotation with the transform of the IK foot bone. So let's reconnect this. It looks like, let me check the curve in the advanced locomotion system animations. So if I go to animation examples, base, locomotion, and let's just get a walk forward. Oh, not that one. So where does ALS lock the feet? Turn in place maybe? Oh, I spelled turn wrong. Here we go. Okay, that's interesting. So, and our left foot would be right here. So, I guess it's unlocked. Now it's locked. It's hard to tell if I don't force a root lock. Okay, so it is unlocked. Now it is locked. So one, it is locked. Now it's unlocked. And there's also a smooth transition down to a sharp transition back up. So unlocked, locked, unlocked. Okay, so that matches up with how I did it, but why does it seem like it's backwards in the logic then here? Because if current footlock alpha is greater than 0, then that means it's locked, so I shouldn't be setting them when they're locked. I should be only setting them when they're unlocked. But so let's disconnect this. We're going to use world space. And if this is false, we're going to update that location. And of course that'll mess things up because, gosh, it's getting closer and closer to how I put the logic in for my original setup. So maybe it wasn't worth all this. I should have maybe just continued to work on that, but oh well. We're now going to use world space and world space. So we're not using this function. We're just setting these. Okay. Let's see what happens. Yeah, that seemed to work. Yeah, foot locking works. Awesome. It worked. And I was able to bypass all of this, which might be needed for the way the advanced locomotion system does turn in place, but I don't need it. So, awesome. Awesome, 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 awesome. Why did it break when I deleted this? Oh, I deleted the return. Okay. There. Okay, so now... Oh, hey, so I'm working on getting a footlocking set up so that I can use an orientation warping start instead of a blending start. I'll show you. I have it. Actually, I just undid a couple of things, maybe a couple of too many. Yep. So it actually works. You have to smooth the transitions a bit, but I didn't like the way the blends looked for the starts, so I decided I wanted to use orientation warping instead, but that would rotate the legs around from the blend between idle to starting. So instead, I'm locking the feet during the start animations. Nope, I am not using stride warping yet. That is going to be one of my next steps. Now I just want to go back into these. Okay. Oh yeah, that's odd. Why does it look like... Oh, okay, it does look fine. So now the way the advanced locomotion system did it is that these were set, not these. These were set to auto. I think. Let's look at this. Yeah. So let's see. I don't think that's going to line up well. but it's going to mean a smoother transition. So we'll try it. And I'll want to do the same thing for the jog forward start. And for the other foot on jog left start too. Yeah, I'm definitely going to need to scoot these around. Yeah. So let's see here. So yeah, it should be completely locked until here. And then it should go back up. But it should be a smooth transition from here to here. There we go. Oh, awesome. You'll have to show me how you set that up for okay. So this is right foot down. So that's it's up. Honestly, that should be there. So it's locked here. Yeah, I'm not sure. This is a bit odd, but I'll try this setup with the curves. Oh yeah. Yeah, that's a yeah, I should definitely enable that in my loop state too. I'm not trying to select all of these, Unreal. There we go. Oh, yeah, that's interesting. Okay. I'll definitely want to take a look at that then, because that is might allow eventually both backward facing strafing and forward facing strafing, similar to how the advanced locomotion system does it. Okay, that looked nice. But I'm not sure if I remember to update it on both of these with forward. Nope. Let's undo that. I think I messed something up there. Oh, that's useful to know. Okay, so I'm gonna go back to this one. And that one. Okay, so back into my left start. So, don't know why this just looks off to me at the forward start, but oh well. It looked off to me with the left too, and then the left foot looked good, so. Ah, okay. And Alexander, it should be possible to add distance matching into the advanced locomotion system, but it would take a lot of work. It would take a good amount of work because there's a lot of stuff going on with the foot locking, with the starts and stops, and how it deals with all of that that you'd be replacing with your own thing. So ALS does a pretty good job with starts and stops with the foot locking system it has. Um, Personally, my personal preference would be just to build a new system with distance built around distance matching. Um, so it might be more effort than it's worth to try to fit distance matching into the advanced locomotion system. Yeah, I agree with misguided game. Just I'd say pull what you like from the advanced locomotion system into your own system, like I did with part of its foot locking system here in this stream. I see. So if I go back over into my jog left start and I look at this, it should be, this should be here. I really messed this up. Big time. Oh no. How much can I undo? Can I undo enough? Let's see. And if I set this all back to constant. Let's look at this. This is the left foot down. So it does sort of make a little step there. Now it's down, now it's up, now it's down, now it's up. So with the advanced locomotion system, just while it picks up, okay, so it's a smooth blend while it's up. So it's from this point to this point that it's smooth. So if I change this to auto, that's not going to do it. But if I pull this up and this down and change this to auto and then this up and this down and I reverse it, changing this to auto, this down, changing it to auto, and then this one up. Let's see. I might need to scoot these around a bit more, so yeah, this is left foot down, so it's up, but it's back down at this point. So really, it should be, when does it go first go up? So there's a step I'd consider. So yeah. So this should be here. And that should be about there. Because it's immediately up until it's, yeah, it might as well be up that whole time. So I could add a key and it might look good if I set this key to 1 and set it to auto. And now, so it's up, but at this point it is down by here.